Hi all. Now we are going to talk about and see about the file concepts, challenges in file system, scalability, managing large volumes of data efficiency is a significant challenge for modern file system. Ensuring performance does not degrade with increased data size is crucial. And we have already seen all those things and overview of the input and output systems, input and output hardware components. What are the input and output devices? Hardware components like keyboards, mice, printers and disk drives. Device controller interface between the IO devices and the system bus, responsible for handling data transfer and device management. Buses, communication pathways that connect the CPU, memory and IO devices. Example include PCI and USB and SATA. Operations. Operations are polling, interrupts, direct memory access. Polling, the CPU repeatedly checks the status of an IO devices to see if it is ready for data transfer. Interrupts, the device sends an interrupt signal to the CPU when it is ready, allowing the CPU to perform other tasks until the device is ready. Direct memory access allows devices to transfer data directly to or from memory without CPU intervention, improving efficiency. Application I/O interface. Application programming interface provides a set of functions and protocols for applications to interact with the I/O system. Common APIs include Unix file-like systems and Windows API for Windows. And example functions: open, read, write, close for device-specific operations. Device drivers, software modules that translate generic input-output requests from the API to device specific operations. Responsibilities: initialize devices, handle interrupts and perform data transfers. Kernel input and output subsystem. Buffering, temporarily stores data in memory to accommodate speed differences between the CPU and IO devices. Types: single buffer, double buffer and circular buffer. Caching, stores frequently accessed data in faster storage to reduce access times. Example: disk cache, page cache. And this is the example of kernel, shell and application. Spooling, manages device access by queuing jobs for sequential processing, commonly used for printers and batch processing. Example: print spooler. Error handling, detects and corrects error that occur during data transfer, include mechanisms like checksums and retry logic. Streams, a stream is a continuous flow of data between a source and a destination, managed by a operating system. Types: input streams and output streams. Input streams in the sense we all know about keyboard input. Output streams in the sense monitor or printer, whatever. Implementation: file descriptor, abstract identifier for open files and IO streams in a Unix files-like systems. Pipes, mechanisms for inter-process communication that allow data to flow from one process to another. IO performance, factors affecting performance. Throughput, the amount of data transferred per unit of time. Latency, the time it takes for a data transfer to begin after a request is made. Device speed, the inherent speed of the IO device, such as disk rotation speed or network bandwidth. Optimization technique, asynchronous input and output, allow the CPU to continue processing while waiting for input-output operations to complete. Multi-threading, using multiple threads to perform IO operations concurrently. Load balancing, distributing IO operations across multiple devices to avoid bottlenecks. Mass storage structure overview. The purpose of mass storage refers to devices that store large amount of data persistently, such as hard drives, SSDs and optical disk. Efficient management of these devices is crucial for performance, reliability and data integrity. Disk scheduling, algorithm first come first served serves request in the order they arrive simple but can lead to long wait time.